Hi, this is Don Whalen with Team 3 from the distance learning student groups. And I'm going to talk about testing and evaluation and deployment. So, let's start here. So, in order to determine which of our four models was best able to predict accidents with severe injuries, so those with a designation of high in our injury severity binned column, we used ROC curves and confusion matrices for each of the models, and we had an aggregated one at the end. So based on the ROC curve, the neural network performed the best. It was best able to distinguish between high and low and predict. However, if you look at the confusion matrices, which we will in a couple slides, the decision tree gave us the most accuracy. So, and as you can see here, let me make this a little larger. There we go. So, as you can see, the blue line here is the neural network. It came in at 0.9197% accuracy, so almost 92%, which is very good. Coming in second place, logistic regression, the red line. And you can, the numbers here tell it, but you can also just tell that there's more, the most area under the curve, literally for the blue line, and then descending all the way to the green line. But for the red line, logistic regression, a little bit behind neural networks at 0.9097, almost 91%. Still very good. The purple line is naive bias, came in at 0.8885, almost 89%. And the worst of all was the decision tree, which was at 0.7553. The tough part is that with the neural network, you get the black box effect. So it's tough to tell which factors contributed the most. But let's move on. And if you're looking at the confusion matrices, the best performing model was the decision tree at 85.963% accuracy. Interesting enough, because the decision tree, as we just saw, performed the worst when looking at the ROC curves. So, but looking at the confusion matrices, second place was neural network at 85.805%. Then logistic regression at 84.746%. And coming in last was naive bias at 78.235% accuracy. And this is a snapshot of the four confusion matrices side by side. And you can see those figures here again. So 85, very close, 84 and 78. Let's see. And getting into the deployment phase, it's the last step in the CRISP-DM process. It's also the most important one. So we've run the models, we've gained the information, and it's now time to act on them. So decision makers, lawmakers can use this data to hopefully minimize the risk of severe injuries, so fatalities and severe injuries in automobile accidents. But it has to go a step further. So the maintenance of these models is very important. So it needs to be determined how often new data will be gathered and new models will be built, tested, and run, so that these decisions aren't just made one time and it's decided this is what we're going to do, but how are we going to continue to make sure that we're protecting people on the roads, protecting everyone with the most current data. So the deployment phase is where we present this information to the decision makers, and it's up to them to decide how often they want to renew this project so that we're keeping everyone safe. This information can be used in order to educate the public and potentially influence car production companies and government agencies that work with roadways. Thank you very much.